Hello everyone. The topic that I will be covering in this talk is how to perform a fine-grained intra-domain bandwidth allocation against the DDoS attack, especially towards the transit link. This project is a joint work together with Zhang from China Academy of Information and Communications Technology and Xiao Zhang, Yiming, Xiao, as well as Zhiming Zheng from Beihang University and Pengcheng Laboratory. DDoS attack is distributed denial of service attack. And these attacks are a type of cyber attack designed to overload servers or disrupt network services by overwhelming them with access requests. We list some of the most famous recent DDoS attacks in real world. That the DDoS attacks as a means of network availability are becoming increasingly intense and sophisticated. And now, let's start with the example of such a small network. The blue node is the endhost, maybe legitimate users or botnet, and the orange node is the router to transmit the data packets. A traditional denial of service attack is to select a particular server as the attacking target, while the denial of service attack towards the transit link is to attack the infrastructure connecting the network by choosing a transit link as the attacking target. Such an attack can be launched by the botnet sending many small flows from many different sources to different destinations. And all of these flows have one thing in common, and that is they cross one particular link. And academic studies have already proposed the attacks as link flooding attacks. We notice the attacking features. As said before, the individual flow are very small and can appear like normal network traffic, so it is very hard to identify such an attack. The volume of each flow individually is small, and the aggregate volume is enough to congest the victim link. And the attacking target, namely the transit link, is usually outside the final victim area, so it is also very hard to locate the real target. To mitigate a large-scale volumetric DDoS attack, researchers are actively exploring capability-based resource allocation mechanisms to manage an effective admission control of transit link. And we now simply introduce how does the capability-based mechanisms work. First, the sender initiates a capability request. And second, if the on-pass AS approves the request and is willing to reserve the bandwidth for the request, it will generate a cryptographic token as an accessing ticket. And if all the on-pass ASs and destination AS generate the cryptographic token, all the tokens will comprise the final capability, and the capability will be sent back to the sender. Now, if the sender wants to send traffic, it will attach the packet with a capability to obtain a higher priority. We list some previous works as a related work. They are all capability-based resource allocation mechanisms, and the difference is they select different allocating granularity. And the granularity is from per flow to per user, namely per source or per destination, and per computation, and finally to per AS. The tricky problem is how to select the allocating granularity. The granularity, such as per flow or per user, will lead to tragedy of the network link comments. This means if an attacker leverages many bots to compete for the link, the allocated bandwidth for each flow or each user will be too small to be used. And on the other hand, the granularity of each domain is too coarse-grained because a domain-level bandwidth guarantee is insufficient to protect legitimate users within an contaminated source S. And we present our solution. That is FIBA, a fine-grained intra-domain bandwidth allocation mechanism, and it will have the following two properties. The first is user-level DDoS resistance. That means the scheme should establish hierarchical channels for capability requesting packets to realize the traffic isolation between benign users and misbehaving users, even when they are from the same source as. And the second property is allocating reasonability. The source domains are able to realize differential local intra-domain bandwidth allocation. Namely, the mechanism should be able to provide differential bandwidth guarantees for active users or ordinary users from a certain source domain. The overall goal of FIBA is to enforce fine-grained accessing control of network capability. The capability enables legitimate user pairs to acquire a guaranteed accessing admission of prioritized bandwidth. And the fine-grained means that the source domain can differentially control the accessing priority of capability to its internal users. So now we looked at the overview of FIBA. The FIBA can be processed in 4 parts. First, source ASIs enforce the allocating index measurement by considering 2 attributing factors. And second, source ASIs attach a suitable tag for each capability request. And third, the transit ASIs leverage the hierarchical queue to execute the admission control for capability request. And finally, the capability can be established hop by hop. And we first introduce the allocating index measurement. It is based on the client's behavioral network, and the key component is to calculate the allocating index, which contributes to 2 factors, namely centrality factor and legitimacy factor. The centrality factor is to defer active ordinary users, and it will consider the topological information, namely the spreading influence connected from the normal state of the users. And the legitimacy factor is to consider traffic features to defer benign users or misbehaving users, and it will be calculated based on the malicious behavioral information collected from the users. And now we introduce how to realize differential admission control. The transit ASIs establish hierarchical channels for multi-state capability requests. And the AS identifier and tag are used to identify the first level queue and second level queue. Therefore, if the attacker launches a DDoS attack by sending a large number of requests, the misbehaving requests will be put into the subqueue with no priority due to their no legitimacy factor, while the requests from active benign users are put into subqueue with high priority. The accessing priority of legitimate users will not be influenced. So, based on the two ideas, the fine-grained accessing control of network capability can be achieved. And next, we leverage Benny Simulator to evaluate our mechanisms. We present the network topology here. There are uncontaminated LCs and contaminated LCs. And the uncontaminated LCs only contains the legitimate clients, and the contaminated LCs contains both the clients and the attackers. And all the end hosts are competing for the bandwidth of bottleneck. And next, we will evaluate our mechanism in the following three aspects. To evaluate the domain-level DDoS resistance, we compare fiber with two relevant approaches. As the number of both increases, as the picture, fiber and Tumblr can maintain the bandwidth guarantee of botnet link for legitimate access, while the curve of TVA witness is a descent. Note that the slight fluctuation of fiber and Tumblr is resulted from natural loss of packets. So, fiber and Tumblr are able to hold the domain-level DDoS resistance. And we evaluate the user-level DDoS resistance. We compare the success ratios of legitimate users and attackers, and can be seen in the picture. Only the success ratio of attackers are decreasing. The dashed line indicates the success ratio of legitimate users from contaminated as in simple per-client file sharing scheme. Hence, in simple per-client file sharing scheme, legitimate users from contaminated as are influenced by the attackers. However, fiber is not influenced. Fiber hierarchical channels contribute to independent channels for benign users in contaminated access, which confines the attacking effects in the low-tech channel. So, fiber performs the user-level DDoS resistance upon domain-level DDoS resistance. We finally evaluate the allocating reasonability. We observe the success ratio from the legitimate access. As with the increasing of number of the capability request packets, the successful ratios of both text requests witness a decline trend. The dashed line is the average successful ratio in per-client file sharing scheme. The curve of high tech is consistently higher than the curve of medium tech, which indicates the requests in high queue obtain more bandwidth guarantee. Thereby, fiber can achieve reasonable allocation by providing differential local intra-domain bandwidth guarantees for active users and ordinary users. And now we conclude our work. We present fiber, a fine-grained intra-domain bandwidth allocation mechanism. According to the topological effects and traffic features, fiber measures the state of request packets among diverse clients during capability establishment. Moreover, fiber is built with hierarchical channel, to achieve differential accessing control of capability and traffic isolation. Besides, FIBA realized the two properties, namely the user-level DDoS resistance and allocating reasonability. And thank you for your listening.